Namaskar, hello and a very warm welcome to CIET NCERT's special live phone-in interactive program. Department of Education in Math, Science and Mathematics NCERT brings you this webinar series Listening to Learn यानी सुने और सीखें। आज हम 118वें सत्र में हैं और आज जिस विषय पर बातचीत होने वाली है वो आप सबको बहुत पसंद आएगा। हम बताना चाहेंगे आज का विषय है ओर्स एंड मिनरल्स एंड देयर इकोनॉमिक इम्पोर्टेंस यानी कि खनिज अयस्क और उनका आर्थिक महत्व। अगर आपके पास कोई सवाल है, कुछ पूछना चाहते हैं, कुछ भी जानना चाहते हैं तो आप हमारे इस कार्यक्रम से जुड़ सकते हैं। आप चाहें तो हमें फ़ोन कीजिए, नंबर है 8800440559। If you want to email us, the email ID would be dth.class12@ciet.nic.in. At this moment, you're watching us on PM E-Vidya channel number 9, 10, 11 and 12. इसके साथ ही आप इस वक्त हमें देख रहे हैं हमारे YouTube चैनल पर भी जो कि है NCERT ऑफिशियल। आप चाहें तो उसके लाइव चैट बॉक्स में भी अपने सवाल लिखकर हम तक पहुंचा सकते हैं। आपको एक गूगल फॉर्म उसी YouTube चैनल पर दिख रहा होगा। अगर आप नीचे अपने सवाल लिखते हैं और हमें वो गूगल फॉर्म भी भरते हैं तो आपको एक पार्टिसिपेशन सर्टिफिकेट भी दिया जाएगा। कार्यक्रम 11 बजे तक जारी रहेगा। बहुत सारी बातचीत होगी आज के इस स्पेशल टॉपिक पर और आपकी सलाह भी हम लेना चाहेंगे। अगर आपके पास कोई ऐसा टॉपिक है, कोई भी ऐसी सजेशन है जो आप हमें इस कार्यक्रम के लिए सजेस्ट करना चाहें, आप चाहें कि फ्यूचर में हम आपके टॉपिक्स लें इस प्रोग्राम में, तो आप वो भी हमें लिख कर बता सकते हैं। इसके अलावा हमारे साथ हमारे मौजूद है हमारे इस प्रोग्राम के कोऑर्डिनेटर और जिन्होंने इस पूरे प्रोग्राम को सक्सेसफुल होने में पूरा क्रेडिट उनका जाता है और डिपार्टमेंट ऑफ एजुकेशन इन साइंस एंड मैथमेटिक्स से ही बिलोंग करते हैं। हमारे साथ हैं डॉक्टर गगन गुप्ता। सो अ वेरी वार्म वेलकम टू डॉक्टर गगन गुप्ता सर।
नमस्ते तन्वी जी, नमस्ते दोस्तों। आज एक बार फिर से मैं आपके सामने हूँ। आज इस प्रोग्राम का 118वां सत्र है और इस प्रोग्राम में हमने जो अगस्त 2021 से प्रारंभ किया था, आप सभी लोगों के सहयोग से, आप लोगों के सुझाए हुए विषयों पर हम लोग आगे बढ़े हैं और लगातार आगे बढ़ते रहे हैं। जैसा मेरे साथी तन्वी ने बताया कि आप हमारे को अपने सुझाव देते रहें, हमें इस प्रोग्राम को आगे बढ़ाने में बहुत सहायता मिलती है। साथियों, आज का जो प्रोग्राम है, जैसा मेरी साथी तन्वी ने बताया, ओर्स एंड मिनरल्स एंड देयर इकोनॉमिक इम्पोर्टेंस, ये एक बहुत इम्पोर्टेंट विषय है, बहुत ही सामयिक विषय है। आपको ध्यान होगा अभी पिछले कुछ दिनों वाइट हाउस में भी रेयर अर्थ्स और दूसरे मिनरल्स को लेकर के चर्चा हुई और इनको हमारे देश के परिप्रेक्ष्य में भी देखें तो इन ओर्स और इन रेयर अर्थ मटेरियल्स को लेकर के काफ़ी चर्चा चल रही है, जो कि विभिन्न उपयोगों में लाने के लिए बहुत लाभकारी ये मटेरियल्स होंगे। आप याद कीजिए, हमने 2022 में जनवरी 28 जनवरी 2022 को डॉक्टर DM बनर्जी मेरे साथ मेरे स्टूडियो में थे। उन्होंने एक वार्ता शुरू की थी, द ब्यूटीफुल वर्ल्ड ऑफ जेमस्टोन्स। आज का एक प्रोग्राम उसी क्रम में आगे देखा जा सकता है। ये जनवरी 2022 का प्रोग्राम आप हमारे ncert.nic.in के इवेंट सेक्शन में जाएं, वहाँ पर वेबिनार सीरीज़ लिसनिंग टू लर्न पर टॉगल करें, आपको वहाँ पर इस 2022 का प्रोग्राम आपको मिल जाएगा। उसी क्रम में आज मेरे साथ बहुत ही इम्पोर्टेंट व्यक्ति मेरे साथ हैं, जिन्होंने कि ओर्स एंड मिनरल्स पर अपनी पूरी ज़िंदगी दी है, अपना पूरा कैरियर उस पर बनाया है। डॉक्टर KV कृष्णमूर्ति, हु इज़ प्रेजेंटली द जियोलॉजिकल सोसाइटी ऑफ इंडिया। आपका बहुत बहुत स्वागत है डॉक्टर कृष्णमूर्ति। हम आभारी हैं डॉक्टर कृष्णमूर्ति के, जियोलॉजिकल सोसाइटी ऑफ इंडिया के, जियोलॉजिकल सर्वे ऑफ इंडिया जहाँ पर कि डॉक्टर कृष्णमूर्ति रहे, एंड मेरे अपने अग्रज, मेरे अपने सीनियर दूसरे प्रोफेसर हर्ष कुमार गुप्ता, जिन्होंने कि हमें डॉक्टर कृष्णमूर्ति के साथ कांटेक्ट बनवाया और इंट्रोड्यूस किया। मैं धन्यवाद ज्ञापित करता हूँ डॉक्टर कृष्णमूर्ति आपका कि आपने और जियोलॉजिकल सोसाइटी ऑफ इंडिया का, जिन्होंने कि NCERT के साथ इस प्रोग्राम को करने के लिए अपनी सहमति जताई। साथियों, आज अपने सवाल आप हमें लगातार भेज सकते हैं। मैं आपके सारे सवालों को लेने का पूरा प्रयास करूंगा। मेरी साथी, मेरी सहयोगी तन्वी और मैं दोनों बारी बारी से आपके सवाल आपके द्वारा जिज्ञासाओं की बात हम करेंगे। आप कुछ भी सवाल पूछ सकते हैं, जैसा भी आपके मन में आए, और ज़रूर दीजिएगा। इससे पहले कि मैं डॉक्टर कृष्णमूर्ति से रिक्वेस्ट करूं कि वो अपना भाषण शुरू, अपनी वार्ता शुरू करें, अपनी बातचीत बताएं, मैं आपकी एक बहुत जल्दी से संक्षेप में उनसे मुलाकात कराना चाहता हूं। डॉक्टर के वी कृष्णमूर्ति, जो कि इस समय सेक्रेटरी ऑफ जियोलॉजिकल सोसाइटी ऑफ इंडिया में हैं, बेंगलुरु में हैं। यूनिवर्सिटी ऑफ मैसूर के एलुमनस हैं, जहाँ से उन्होंने बीएससी और एमएससी किया जियोलॉजी में। उसके बाद यॉर्क यूनिवर्सिटी ऑन कोलंबिया प्लान फेलोशिप पर 1990 में उन्होंने एक एडिशनल एमएससी एडमिनिस्ट्रेटिव साइंस पर किया। बहुत जाने माने व्यक्ति हैं। इन्होंने 1979 में 1979 में ही जॉइंड द जियोलॉजिकल सर्वे ऑफ इंडिया, which is also called GSI, and he began his services in the Kashmir Circle of northern India. Contributed a lot for the geological mapping of and mineral investigations in Ladakh, Kashmir, Kumayu Himalayas, Raichur Hills of Karnataka. He in 1986 he was deputed to the Planning Commission, which is now called Niti Aayog, New Delhi, where he played a key role in drafting 5-year plans for minerals and industrial sectors. As a part of the 15th Indian scientific expedition to Antarctica, Dr. Krishnamurthy mapped charnokites and granites in East Antarctica or even mountains under extreme conditions. Delhi is also very cold now. Delhi is also becoming slowly colder. So we have started feeling cold here, but not as Antarctica is. Dr. Krishnamurthy later trained young geologists at GSI's Training Institute, Chitradurga, and led divisions in remote sensing and aerial surveys of Geological Survey of India, Bengaluru, specializing in photogeology. We will take up another session on photogeology soon. Hyperspectral analysis, airborne surveys, and technical coordinations. In 2014, Dr. Krishnamurthy was promoted to the Deputy Director General, and he served as Regional Mission Head to Southern Region, Hyderabad, until he was superannuated in 2015. Post-retirement too, Dr. Krishnamurthy is very active and has worked as a consultant in Africa, completing a limestone resource project in Congo. A life fellow of several institutes in geological sciences, Dr. Krishnamurthy has published more than 40 research articles in peer-reviewed journals. Once again, welcome Dr. Krishnamurthy to our studio at New Delhi. It's all yours now.
Thank you, sir. Thank you, Professor Gupta Sahab, for that wonderful introduction about the subject as well as myself. I am thankful to NCERT for giving me this opportunity to share my knowledge about ores and minerals and their economic importance. In fact, we geologists, not only we study ores and minerals, we breathe ores and minerals every day when we go to field. They are part and parcel of our life itself. Before I start my talk, I welcome all our viewers. A very good morning to you all. So, I am dealing this topic ores and minerals. Wherever you feel like asking questions towards the end, you may ask. Let us come to the topic. What are ores? Ores are nothing but they are minerals, of course. They contain a high enough concentration of a metal, a specific metal or any metals, making it economically viable to extract that metal. Otherwise, all the metals whatever you see today in our day-to-day life, they are all extracted from the ores and minerals. For example, hematite is a ore of iron, chalcopyrite is a ore of copper, and chromite is a ore of chromium. So, here these are the figures just for your reference. I am giving these figures. They look alike or they have got different shapes and physical properties. I will come to that later on. To give some more examples of ores, this is called banded iron formations, we call BIF. They are the very good source of iron. So, they have got different names altogether depending on the type of minerals which is occurring in that bands. These are the alternate bands of iron and chert or quartz you can call. So, we call this as iron is made of hematite, banded hematite quartzite, it is called BHQ. Similarly, we have got BHJ, that is banded hematite jasper. This red color is the jasper, that is why we call banded hematite jasper. They are the very good source of ore for iron. Further, for ores of iron, there are so many other minerals, rather I should say, banded iron formations is nothing but they are alternating bands of iron and the quartz material, and they are mainly sedimentary rock sources. And we have got banded magnetite, in fact we call BMQ, banded magnetite quartzite, that is also the ore of iron. In fact, these are all examples I am giving you, ores of iron and manganese. Further, there is pyrite. Mainly we use this for extracting sulfur, because though iron is also there, but then for iron, as I told you in the beginning, hematite and magnetite are the main sources. Likewise, we have got manganese ore, which is called silomelon. It has got kind of a botryoidal feature, and that is mainly used for extracting manganese, another important mineral. Just to have a background knowledge about how India is, whether it is self-sufficient in some minerals or deficient in some minerals. Iron ore, for example, we are the leading iron ore producers. We are the second largest producer of iron ore. That's why we are the second largest manufacturer of steel. And then we have got bauxite. India holds a significant global position in bauxite reserves and production. So, we have got bauxite is the ore of aluminium. We export in fact both iron and bauxite, getting lot of foreign exchange through that. Then we are self-sufficient in chromite, which is very important mineral for extracting chromium. Likewise, we have got plenty of coal, but ironically, though we have plenty of coal resources, but then certain type of coal, that is called coking coal, which is used in blast furnaces for steel making, we are still importing, because India is lacking in coking coal resources. Then we have got sufficient mica. India is largely self-sufficient in mica, because like we call Nellore mica cyst belt in Andhra Pradesh, that contains lot of mica. Then we have limestone. You may be knowing that limestone is used for manufacturing cement. In fact, India is the second largest producer of cement in the world, because we have got enough resources of limestone all over the country. Then come to the ores of aluminum. Here you can see three different types of ores are given. The first one is called gypsite, which contains aluminum hydroxide. You can see the physical features are different, though they are the source for aluminum, but their physical feature is different. For gypsite, you have got a kind of massive botryoidal texture. Then you have bohemite, which has got dotted appearance. Then you have got diaspore, which is again a aluminum hydroxide. And these ores are used to extract aluminum. We have got plenty of minerals in some aspect, like iron, bauxite, what I dealt just few minutes back. We are deficient in certain minerals. Which are those? We do not have enough copper deposits in India, though we do have some, but it is not sufficient. So, we have to import copper. Then we have got nickel and cobalt. India is highly dependent on imports, because we are too insufficient in nickel and cobalt minerals. Then you might have all heard about lithium these days because of the critical minerals. Lithium is playing very important role in automobile industry. Without lithium batteries, it is difficult to run the electric cars. So, we do not have significant reserves, though of late it is in the news that India has discovered lithium deposits here and there, but then we are yet to have the technology to separate lithium from the lithium ore. That is another issue we have to debate on. Then petroleum, India is heavily dependent on imports to meet its petroleum requirements. You know, day to day our vehicle population is increasing day to day, and then in the process we do not have sufficient petroleum deposits in India. So, a huge exchequer is being incurred to import petroleum. Then come to gold and silver, which is dear to all our household people. Rather, ladies are very important in the sense that they go for gold purchasing on some occasions, but then friends, you may be knowing that we have got very little deposits. Earlier we had Kolar gold fields, that is KGF, which is now abundant. Then we have got Hatti gold mines, where we are extracting gold to the tune of only 2 tons, not even million tons, whereas we require nearly 800 to 850 tons of gold per annum. Imagine the amount of gold we are importing. So, we are insufficient in all these minerals, ores. Now, let us come to what are minerals. So, you may be getting confused ores and minerals. So, minerals are normally they are occurring as inorganic substances with a defined chemical composition and crystalline structure. You can see here, this is a quartz, it has got beautiful crystalline structure, we call it as hexagonal crystal structure. Then it is in a different forms. Then lot of these minerals are found in the earth's crust. Example, I told you quartz, this is felspar, which is pink in color. In felspar also there are different types of felspars. One is potash felspar, we call that as orthoclase or microcline. Then we have got calcium felspar, which is called as plegioclase. Then we have got calcite, it is nothing but calcium carbonate. This is a source for calcium carbonate, and all these minerals are all ores are minerals, but not all minerals are ores. There is a very tricky thing here. All ores are minerals, because ores have to be comprised of minerals only, whereas minerals need not be ores. I will explain you why it is so. The differences I can quote here. Minerals from which metal is extracted profitably, they are called the ores. So, you mean that ores are nothing but minerals, but then you can extract metal profitably, without incurring much expenditure. So, minerals, whereas minerals they are not ores, because they are naturally occurring inorganic substances where metal content may or may not be high, whereas you find high concentration of a specific metal, for example, gold or copper or silver in the ores, and ores are profitable to extract in metals which it contains, whereas these minerals they are not necessarily profitable to extract. Now, how do we identify minerals? See, we geologists, we go to field and our job is to map an area to find out what are the minerals or ores present in there. So, you require certain properties of the minerals to identify them, because we should have that knowledge. Minerals are identified by their distinct physical properties, which are direct result of their unique chemical composition and internal crystal structures. For example, what are those properties? The main properties we identify minerals depends on this hardness, cleavage, fracture, luster, streak, color and specific gravity. For example, what is hardness? The hardness is nothing but the resistance of a mineral to scratch or measure using the Mohs hardness scale, because I will tell you there is one hardness scale is there from 1 to 10. The softest mineral is given hardness 1, that is talc. You all know about talcum powder, that is made of from talc, that is the softest. If you just make a scratch with your nail, it will scratch. So, that is one hardness, whereas diamond is at the extreme end of the Mohs scale. That diamond is the hardest substance in nature, its hardness is measured as 10. So, that is one property to identify a mineral. Then we have got luster. What is luster? It is nothing but the appearance of a mineral surface when it is exposed to reflected light. So, under this we have got metallic minerals or non-metallic minerals. Examples: pyrite, which is also called as fool's gold, because it is looking like your gold only, but then it is pyrite, is made of iron sulphide. It has a metallic luster, while quartz has a vitreous or glassy structure luster, and it is non-metallic luster. So, that is example for luster. Then we have got another property to identify a mineral by its streak. What is streak? The color of a mineral in its powdered form, which is more reliable identification property than the mineral's body color, because body color may be, you may be looking it as a red color or brown color. When you scratch it on the streak plate, it is a hard ceramic plate, you get the powder of that will have a different color. For example, hematite is a iron mineral, it is grey or reddish brown in color in the physical look, whereas when you get its streak, it is red brown. It is the characteristic property of hematite, that is iron mineral. There is one more important property, we call it as cleavage, the tendency of a mineral to break along smooth flat planes of weakness in its crystal structure, that is called, you might have seen the mica occurs as a sheet, that is because the cleavage planes are like that, horizontal planes. So, you can cleave them along the cleavage planes. So, that is another important. Then the halite is nothing but common salt, it exhibits cubic cleavage breaking into cube shaped pieces because of the cleavage property. Then we have got another physical property known as fracture, the way a mineral breaks in directions other than cleavage. So, this is cleavage, fracture can be across that also, typically along irregular surfaces. Example is quartz and obsidian. Obsidian is a glassy material of volcanic origin, black in color. It exhibits conchoidal fractures, both quartz and the obsidian. It produces smooth, curved and shell like surfaces. Example, native copper shows a hackly, means zigzag fracture. Coming to color, while it is an obvious feature, but it can be unreliable, as I told you for hematite, for identification, as trace impurities can change the color of some minerals. Example, azurite. Azurite is a copper ore, it is always blue in color, whereas malachite is always green in color. It is a very diagnostic or characteristic property of these ores. However, pure quartz can be colorless, as I showed you in the first or second slide. Pure quartz is colorless, but when some impurities are there, it can give either white or pink or purple colors depending on its impurities. So, this is the example. See, this is the quartz and this is also quartz, but then because of the impurities present in that, it gives a beautiful, very pleasing colors, pink, purplish color. So, we call this as amethyst. It occurs within the Deccan basalts, plenty of amethyst we do have. Then coming to another property, that is called specific gravity. You can identify a mineral by by measuring its specific gravity. You need not measure, you can take them in the hand. For example, I say we call volcanic ash as a tuff. Tuff material is very light. If you go and take a ore of gold or galena, they are very heavy. They are gold has got the highest specific gravity. It specific gravity varies from 15 to 19, whereas galena is the ore of lead, that is also quite heavy. So, based on their specific gravity also we can identify minerals. Then come to crystal form, or we call it as habit of the minerals. The external shape of a well developed unconfined mineral crystal reflecting its internal atomic arrangement is called the crystal form. Example, pyrite always shows cube shaped crystals, whereas quartz shows hexagonal prisms, because quartz crystal is in hexagonal system of crystal system. This is the example for again the galena ore. This is shining material is the all galena. It is very heavy. When you hold the ore in your hand, it is quite heavy. Come to gold, you may be thinking where is the gold in this. So, this is the gold, this yellow shining part, they are occurring in native form. See, the rest is all quartz. So, in a ore we call gangue material which is unwanted for us, that is called quartz is gangue here, whereas this is the gold is very important specks of gold occurring within the quartz. Then there is something called tenacity, a mineral's resistance to breaking or crushing or bending, it is called tenacity. You all know gold is very malleable. You might have gone to a goldsmith shop where he hits and hammers the gold into any shape whatever he wants, that is called malleability. Then micas are elastic, you can elast and expand the mica. Then there is another important property which is called magnetism. Magnetism means it is a characteristic of magnet crystals. In the beginning I told that magnetite is an ore mineral for iron. You bring a magnetite and any other material which is metallic, it attracts, that is called magnetism. Then another property, reaction to acid. You take some dilute hydrochloric acid and put that on any minerals. If it is a carbonate mineral, it immediately gives effervescence, a kind of bubbles will come out of that. That is for example, calcite, it readily reacts with the acid. So, based on that in the field we can identify it is a carbonate mineral, and most of the carbonate minerals reacts with acid. Example, anchorite is a iron carbonate. So, in the field we may not be knowing whether a rock contains anchorite, you just put some acid over that, it immediately gives effervescence. Even limestone and dolomite, they are also calcium carbonate minerals. So, that also they also react with the acid readily. So, based on these physical properties we identify different minerals in the field. Now, let us come to the terminology what is called a rock. It is a very common terminology, we say it is a rock or it is a stone. What is it? A rock is made up of two or more minerals, and you need minerals to make rocks, not that rocks makes the minerals. So, combination of minerals will make a rock. For example, a granite is made of quartz, feldspar and little bit of mica. So, here I am showing the example, this is a pink granite. Why do we call, there are different types of granites, this is the grey granite, this is a pink granite, this is a slightly greenish granite, this is a dark grey granite. So, depending on the mineral composition in it, the granite gives different colors and also textures. The pink granite, because it contains quartz and pink feldspar which is called potash feldspar. Come to marble, marble is also a rock, it is purely made of calcium carbonate, that is calcite is present heavily in this rock. So, that is the difference between, for example, here I am showing a rock, it is called kimberlite. Kimberlite is a rock, ultramafic rock, it contains diamond in it, all important, diamond is present in this rock. So, how it forms? It forms as a kimberlite pipe, it directly comes from the mantle while it is coming out along the fractures or cleavage planes or joint planes, it brings along with it the diamond. Diamond is a high pressure, high temperature minerals. So, this rock contains the diamond. So, that is a rock. Now, there are group of mineral commodities we call, like what are the group? Metallic and semi metallic elements, under which you can say gold, silver, copper, iron, manganese, aluminium. They constitute the metallic minerals. What are the non-metallic minerals? For example, potassium, sodium, phosphorus, sulfur. They are all non-metallic. And we have got plenty of gems. Just now I told about diamond, we have got sapphire, agate. In the next slide I will be showing what are the different gemstones. Then we have got another group called industrial materials. In industrial materials we have got construction and manufacturing materials. What are those construction materials? Like sand, clay, building stone, talc, mica, zeolites and fluorite. They constitute the construction material. Whereas fertilizer and chemicals, there is another group of minerals. Example is your limestone, from which we make manufacture cement, then phosphate, then potash, salt, that is common salt daily we use, then the nitrate, they all come under fertilizers and chemicals. Then we have got another important group of minerals, that is energy resources. What are those? Coal, that is coal has got different properties. Coal is mainly used for your manufacturing thermal power. Then oil, oil comes under this your petroleum comes under the oil, gas, natural gas like your CNG. Then the uranium, all important mineral for nuclear power generation. So, this is the commodity classification. I told you something about gemstone. There are beautiful gemstones you might have all seen, either you put in your ring in the fingers or necklaces. So, wherever you go for gemstones, you will be looking for its pure luster or color, attracting colors, and sometimes you get cheated because we have got artificial gemstones also. Whereas, whatever the gemstones I am showing here is the natural gemstones. It is called muktika, it is a pearl, then pravala is a coral, then vaiduria is a cat's eye, then the vajra is nothing but your diamond, then manikya, ruby, then neela is the blue sapphire, then markata is the green emerald, then pushyaraga, then gomedika. I will give the names, these Sanskrit names and their composition. For example, muktika is nothing but pearl. What it contains? It is organic gem, chiefly aragonite, that is calcium carbonate, produced in molluscus. Then pravala is nothing but coral, it contains organic gem, calcium carbonate skeleton, that is they are all occurring in the sea. Then vaiduria, vaiduria is called cat's eye chrysoberyl, it is beryllium aluminum oxide. Then manikya, manikya means it is ruby, it is nothing but in geology we call this as corundum. Corundum contains chromium giving red color, that is why it is red in color, ruby we call. Then neela is nothing but blue sapphire, it is also corundum colored with blue because mainly iron and titanium materials elements are there in it. So, that is why it gives that. In the beginning itself I told you these colors are nothing but due to some impurities. Then markata is nothing but emerald, which is beryl, that is beryllium aluminum silicate, it is green colored because of the presence of chromium or vanadium. Then pushyaraga or pukhraj we call, that is yellow sapphire, this is again a corundum, that is aluminum oxide, colored yellow usually by presence of, because of the presence of iron in it. Then gomedika is it hessonite garnet, there is a green color garnet we call, that is called grassular garnet. It contains typically honey brown to orange color. So, they are the different names, and this again I am showing you big crystals of diamond, emerald, ruby, and the beautiful tourmaline. There is another mineral called tourmaline, beautiful crystals, you see the colors and crystals. Then Burma ruby is again a corundum. Now, classification of ores and minerals. How do we classify these ores or minerals? So, classification number one is we call sometimes native elements. Native elements means, for example, gold or silver or copper or platinum, they occur in a pure form. They will not be having any gangue material in it. It is called native. Native gold, native silver, like that. Then we have got sulphide ores. What are the sulphide ores? Chalcopyrite, for example, it is a copper iron ore. Chalcocite is a copper sulphide. Bornite is a copper iron sulphide. Covellite is copper. So, these are all copper sulphides, they come under the sulphide ore category. Then we have got galena, that is lead sulphide. Then sphalerite, zinc sulphide. Then pyrite, iron sulphide. Petlandite, iron nickel sulphide. Then cobaltite, cobalt arsenic sulphide. Molybdenite, molybdenum sulphide. Like that, different types of sulphides are grouped under sulphide category. Then we have got another category called oxide ores. What are oxide ores? Cuprite, copper oxide. Hematite, I told you iron oxide, it is important. Magnetite is again iron, ferric iron oxide. Then chromite, iron chromium oxide. Then ilmenite, another important source for titanium, that is iron titanium. Cassiterite for tin, uraninite for uranium, then pyrolusite for manganese. They all are clubbed under oxide ores. Then we have another category called hydroxide, means it contains hydroxyl, that is OH molecule. For example, goethite is an iron hydroxide, gypsite I showed you in the beginning, aluminum hydroxide. Then manganite, it is nothing but manganese hydroxide. Then we have got another category of ores, they are called carbonates. What are those carbonates? Siderite is an iron carbonate, rhodochrosite is a manganese carbonate, then smithsonite is zinc carbonate. So, they are clubbed under carbonates. Even for example, calcite is a calcium carbonate, it comes under carbonate. Then even dolomite comes under carbonate. Then phosphates, we have got xenotime, that yttrium phosphate. Then we have got monazite, very important mineral, mainly occurring in beach sands. It contains cerium, lanthanum, thorium and phosphate. Then we have got sulphate ores. What are those? Barium sulphate is a barite we call, is also very heavy mineral having higher density. Then we have got gypsum, that is calcium sulphide with hydroxyl molecule. So, that is about the different types of classifications of ores and minerals. Now, let us come to the classification of ore bodies. How these ores and minerals are occurring? They are occurring in a different form, I will come to that later on. So, based on shape and morphology, the ore bodies can be classified as discordant or concordant. Discordant means it is at an angle to the bedding plane of a sedimentary rock. Then concordant means parallel to the bedding plane. We call bedding plane where two beds are there, different beds. The contact between two beds are called bedding planes. So, if now I will come to the details about the discordant ore bodies. The discordant ore bodies have a cross cutting relationship, as I have already explained, with the lithological boundaries and or the internal structures of the host rocks. I will show in the figure also. They may be regularly shaped or irregularly shaped. The regular shaped bodies may further be divided into tabular or tubular type of bodies. So, this is an example to show you how the discordant ore body occurs. These are the country rocks, means into which the ore body has intruded in the form of vein. For example, this is shale, this is limestone, the horizontal lines. So, along a fracture, this ore body has entered as an hydrothermal fluid, it enters and then it gets deposited. So, since it is cutting the bedding plane at an angle, it is called the discordant ore body. For example, you can see here it is written footwall, here it is hanging wall. Where do these terminologies are applied? If there is a fault plane, this is a fault plane along which the ore body has occupied, and because of the faulting, this limestone and shale rocks, they have moved down, they become hanging wall. The one which is resting, that is called footwall. Tabular ore bodies, I told you where it is flat. Tabular ore bodies are extensive in 2 dimensions and less developed in their 3rd dimensions. Veins and lodes fall in this category, as I showed you in the previous figure. The veins are generally formed either by the movement of ore fluids through the cavities or fracture planes and infilling the pre-existing open spaces. They are the ore bodies. Then let us come to the another category, that is concordant. So, the one which we described just now is called discordant because it is at an angle to the bedding planes. The concordant would be opposite, that means it will be parallel to the bedding planes. Say they occur as layers parallel to the beddings. Then concordant ore bodies in sediments are very important producers of many different metals. For example, any base metal you take, sometimes we call them as a stratiform base metal deposits. For example, banded iron formation I told you in the beginning, that is BIF, banded iron formation, that banding is along the bedding plane, horizontal bedding plane. So, they are the example for best example for concordant ore bodies. They may or may not be an integral part of the stratigraphical sequence. Stratigraphy means we start from the oldest at the bottom, then the youngest at the top. So, they may not coincide with this, they may form later to the formation of the rock. Such bodies can be present in sedimentary or igneous host rocks. I will give example. See, in this figure it is very clear. So, this is this shale, this is limestone. So, this is the bedding plane. So, this ore body, what is happening here? It is occupying along the parallel to along the this thing sedimentary beds. So, that is why they are called concordant. They are not cutting at an angle, they are just going parallel, because the contact between 2 different rocks, that is weak plane. That weak plane is occupied by these veins of minerals. Then how do these ore minerals form? That is origin. Ore minerals originate from several geological processes, like it can be magmatic, it can be hydrothermal, it can be metamorphic. Different processes are involved for the formation of ore minerals. And superficial process like erosion, for example, you have heard of what is that diamond, Kohinoor diamond for example. That was kind of a placer deposit along the Krishna river beds. Once upon a time there was an kimberlite pipe, that kimberlite pipe got eroded, then the diamonds were floating along the river beds, then it gets deposited. That is called your superficial process or erosional process leading to the mineral deposit. So, let us see the magmatic, hydrothermal and metamorphic process, how it happens. I am showing a cross section of a typical VMS, we call volcanogenic massive sulphide deposits. How it happens? For example, there was a volcano here. Prior to volcano, this is the seabed, that is the seabed, and this is the volcanic eruption takes place. While erupting, it brings in lot of ore minerals, metals. So, what it happens, for example, these are the brecciated and massive sulphides, maybe containing copper or any other metal. Then this is the bedded sulphides here. After this, there is a layer of this. Then you have got paleo seaflow. Okay. Then what it happens means, volcanic rocks, while it comes, it brings in lot of materials from the mantle, from the deep from the earth. This is another example to show how different processes are involved. For example, this is igneous, that is intrusive igneous rocks crystallizes, along with this we get minerals and metals. Then due to weathering, rock gets broken, then it gets deposited here in the seabeds, then they become sedimentary processes. When they get buried deep under the crust, they produce lot of minerals. So, this is an example to show a igneous type of rock containing chromite. These black bands are chromite and this white color one is anorthosite. It contains lot of PGE, platinum group of elements, which are very important, like platinum, palladium, rhodium and all. So, this is another example to show lateritic deposits. Laterite means due to weathering, the solutions carry lot of materials down below, then the residual part contains lot of material, even nickel gets from the lateritic deposits. Then there are some endogenic process, means interior, this is magmatic process, as I told you, nickel, copper, sulfides are the example. Then you have got another important process called hydrothermal process. The hot mineral rich fluids from deep within the earth, they circulate through cracks and they deposit lot of minerals. Then metamorphic process means heat and pressure from metamorphism can release mineral constituents from deforming the rocks. So, we get all the three types of ore mineral formation. Then exogenic process, I told you example of the diamond how we get. Then extraction of ores. So, unless we extract the ore, we are not going to get any benefit from the ores or minerals. How do they extract? Due to mining. So, we carry out mining wherever important deposits are there. There are two types of mining, one is underground mining, one is open cast mining. And the surface itself, if you start digging like in iron ore mines in Karnataka, Bellary, Sandur and all that, we have got open cast mine. Whereas, underground mining means lot of overburden will be there. Instead of digging out all that overburden, we start going through the underground shafts and adits, all that, then we bring out the ores into this. So, once you bring the ores, how do you extract? There are different processes to extract. That is, one is by concentrating the ore, another is by isolating the metal, concentrated ore, then purifying the metal. Then magnetic separation is one type of processing of ore. If the rock is magnetic, so we just make it powder and pass through the magnet, it attracts, then the rest of the non-magnetic material gets away. So, then another method is called froth flotation method, where in order to separate sulphide ores, froth flotation is formed, that is the combination of water and oil. Because of their different characteristics, they get adhere to each other, then they separate. Then roasting is nothing but burning. Then calcination is a process in which a substance is heated to a high temperature in the presence of air. So, we get the metal. Then smelting means another process to smelt or means melt it by heating and melting them, we get the metals. Then lastly, we come to the uses of ores or the application of ores and materials. We talked so much about this. What is the use? Say there is a saying that from pins to plains, you take from pins to plains, ores are involved. Ores and minerals are important raw materials for any industries. Without ores and minerals, we cannot progress at all. Any economic development of a country purely depends on its natural resources or mineral resources. So, what are the technology used? For example, silicon chips, which is used mainly in computers, rare earth elements for electronics, then coal, petroleum, uranium, all these for power generation, then manufacturing of aluminium or vehicles. So, you need aluminium plenty in automobile industry, and copper for copper wires in the electronic industry. They are also used in consumer goods like jewelry, gold and silver. We need plenty of it. So, that is very important uses of the ores and minerals. Then we have got infrastructure and construction. See, these days we talk about huge construction, maybe whether national highway or shipbuilding or construction of housing, you require a lot of materials. They are all come from these minerals. And for example, gypsum is required for plaster of Paris, limestone is required for cement, iron ore is required for manufacturing steel, then granite and marbles are used for flooring. Then in the technology, silicon I told you is used in computer chips, copper for electronic industry, mica for electrical goods. Then energy fuels, of course, I explained already. Then manufacturing industry, that is aluminium, from bauxite we get. Then zinc is used as a corrosion resistance material and also for important, as a medicinal use. It is immunity, for immunity boosting you use zinc. Then titanium is used for paints and also used in space to manufacture planes. Then lead is used in batteries. Lithium, of course, we have heard of for using batteries. So likewise, we have got plenty of applications. Without raw materials, without ores and minerals, I think it is difficult to imagine our life. Thank you very much for your patience. For listening to this.
Great. You have really mesmerized all of us here, sir. आपने इतने जेम्स, ओर्स, मिनरल्स, लग रहा है कि एक सेशन बहुत कम था. बहुत सारी चीज़ें आपने हमें समझाई, बताई. There are some questions which we are receiving from different ends. So you will take up something or the other in the between. You can have a toffee.
Okay, sir.
Stimulate. So you to begin with, you were talking about placer deposits, and then took the example of diamond in the Krishna basin. We often see in movies, in other social media platforms, that gold, as if the gold is being found in its natural elemental form in the basins, either at the beach bases or largely you say the placer deposits.
Placer gold. Yes,
Placer deposits. So is it always found as a placer? So number one, question number one is that whether the gold is always found in the placer deposits, as a placer deposit in the natural form, in the elemental form, or if we have the gold mines, we had in this country we had the Kolar gold mines. So these are not placer.
Yes.
So do we get gold or these kind of materials which are very heavy?
Yes.
You talked about a specific gravity or density. So they are found in the case of in the form of elements only, or as a form of minerals as well.
Very good question, sir. In fact, gold primarily occurs in the form of igneous deposits. For example, in Karnataka there are two important gold mines, which is KGF, Karnataka Goldfield, Kolar Goldfield,
yes,
where it is occurring in the form of veins and ore body, not as placer. Placer comes when these ore bodies are exposed to the surface. Due to weathering, that gold is transported along the river course or something. For example, in Kerala there is a placer deposit. In Shivalik's mountains in Himalayas,
this is again placer.
Placer deposit.
Yes.
Whereas in Hatti, again in Karnataka, this is again an igneous process. It is occurring as an ore. When ore is broken into pieces due to weathering processes, it gets transported. Once upon a time, they were exposed to the surface of the earth. They gets broken due to weathering. They were carried. Then it is called placer.
I will come back to this question, but before Tanvi is having some other question.
Yes.
Yes, sir. So we have Kolkata, and Kolkata is called the geological capital of India. Why is it so, and how?
Yeah, there is a story behind it, madam.
Yes, this is
Because in 1851, Britishers, for the first time, they opened a geological department in Calcutta.
Okay.
Since then, it is growing. At that time, when Britishers started, Thomas Holland started, it was only one-man geologist. Thomas Holland came all the way from Ireland. He was deputed here as a geologist. So he started the office. Now we have got Geological Survey headquarters only in Calcutta, because Calcutta people like it and they don't want to move it also to either Delhi or
otherwise Calcutta region doesn't have that many
not at all. No, because it is situated in a Indo-Gangetic alluvial plain. It's all clay everywhere. There is no. But then those people started because they wanted coal nearby, this Jaria and all those places, Singarani, Jharkhand. It is nearby. So they wanted to go from Calcutta, was their base, East India Company. They wanted to go from there, then explore, and they started this headquarters there. Now we have got our headquarters there only. That's why it is called.
So it's for the historical legacy.
Historical legacy we carry forward like that.
See, in world we have many placer deposits of gold, in particular Swarnarekha Nadi in Jharkhand, Odisha. Can you speak something that
yes,
really,
sir. See, there is, in fact, whenever we go out in a geological field, we ask people, is there any river or nala named after Swarna? There is a meaning in it.
Yes.
In the olden days, people have found gold there. It is a placer gold once again.
It's a placer gold, yes.
So it has brought from some upstream areas, and that is why that is nothing but Swarna Rekha or Suvarna Rekha. These are all names derived because of the presence of gold.
Once upon a time the gold was found,
yes,
but now
people used to pan the gold and take.
Okay, how many years? I mean,
That's
400 years?
Hundreds of years. Yes.
I really find some evidences of having seen it nearly 500 years ago, but I do not know from where, at what time it started.
Yeah,
I mean,
these names are given by the old people because of the presence of gold. They used to pan and take the gold.
Do we have some kind of thing with the other precious materials? You talked about platinum, you talked about
heavy metals we do get along that, but lot of sand beach we have got in Kerala, in Andhra. We have got lot of uranium minerals there.
So that's again placer.
Yes, placer.
That's again placer.
Yeah, that's a very good source for
We have
some
very interesting topic. Very interesting topics are have told us. मेरा तो मन कर रहा है कि आपसे सवाल पूछता रहूं, जानता रहूं. But sir, we have time. Sir, do we have some one or two questions? No. Anyway, please. Carry on. Take on.
Thank you so much, sir, for being with us. It was
my
a
pleasure.
wonderful conversation. जैसे सर ने बोला कि सर का मन कर रहा है क्वेश्चंस पूछते ही रहे. बहुत सारी बातचीत है जो हमें आपसे करनी है, पर मे बी नेक्स्ट सेशन. तो इसी के साथ सर हम ये आपको थैंक यू करना चाहेंगे. हम अपने सभी व्यूअर्स को भी थैंक यू करना चाहेंगे. एंड आई वुड लाइक टू थैंक डॉक्टर गगन गुप्ता. सो थैंक यू सो मच फॉर ब्रिंगिंग हिम हियर एंड मेकिंग दिस प्रोग्राम even more interesting and exciting. Sir, could you please announce the next program that we have lined up?
In the continuity of what we heard today, what we discussed today, we have another session on 19th of December, Friday. You might have noticed today Professor Krishnamurthy was speaking about elements. He touched formation of elements, formation of minerals, ores, etc. We were receiving your request for learning about that, how these elements are being formed. Remember, when we were child, we were say 40 years ago, we were taught that there are only 94 elements. When we grew up, 98 elements. Few years ago, 114. Now it is 118. What's this? So, in order to discuss all these things, we had a session in 2024, September 22, when Uday Mitrav came with us from Indian Institute of Science, and he discussed about all those things. And another issue, we see in nuclear physics, we understand the binding energy curve, and the iron is found at the top of it. We understand that how the elements of up to iron could have been formed by the nuclear fission or fusion processes. Beyond that, it's little difficult to understand. So, in order to discuss that how these elements could have been formed in nature, we are going to have Professor H.M. Antia from the Tata Institute of Fundamental Research, Mumbai, on 19th of December with us in our studio. So, please keep on your questions ready for him. So, we will be meeting again on 19th of December at the same time, 10 o'clock. Till then, goodbye friends. Bye.
Thank you so much, sir, and I'm sure all the viewers, they will be watching the program for sure. And if in case they have missed watching this particular program, they can watch it on NCERT official, that is our YouTube channel, or they can watch the earlier programs as well with the help of this website, that is ncert.gov.in/webinar_series_php. So, thank you so much, Dr. Gagan Gupta, once again for making this program wonderful. Thank you. Thank you, Krishnamurthy sir. Thank you. एंड थैंक यू टू द व्यूअर्स। आई रियली होप आप सब ने ये प्रोग्राम बहुत इन्जॉय किया होगा हमेशा की तरह, और इसी के साथ हम अपना ये कार्यक्रम यही समाप्त करते हैं। पर जाने से पहले बताना चाहेंगे अभी बहुत सारे कार्यक्रम हैं आप सभी के लिए। तो अगला प्रोग्राम जो लाइंड अप है, आप एक झलक शेड्यूल की देख सकते हैं अपनी स्क्रीन्स पर, और 11:30 बजे से 12 बजे तक आप देख सकते हैं ई जादुई पिटारा का ये कार्यक्रम, जो कि बेहद खास है। थैंक यू सो मच, और एक बार फिर से अपना ध्यान रखिएगा, हमारे साथ जुड़े रहिए इन कार्यक्रम के ज़रिए। और मैं हूँ तन्वी खुराना, आप सभी से इजाज़त मांगूंगी। धन्यवाद, नमस्कार।